A very warm welcome to all of you joining us this morning for the workshop on drones technology hosted by the World Resources webinar. And we want to thank Dr. Krishnan Umachandran for his dedication and unstinted service in offering these webinars for the benefit of the international community. I know we have persons from Malaysia, from Italy, from the Philippines, from the Caribbean, where I am from. And we welcome you all this morning. Drones or unmanned aerial vehicles, and we can shorten that to UAVs, are increasingly being used in a variety of remote areas in these sectors. Today's webinar will be facilitated by and of drones. I will now introduce our esteemed presenters. Our first presenter is Dr. Mohammed Faiz. He's from the University of Malaysia, Kelantan. His topic would be drone for rice farming, actual field capacity, operation time, and droplet density during aerial fertilizer spraying in rice field. Dr. Faiz has a PhD in geospatial in precision farming and agrotechnology. He also possesses a master's in plantation management and a bachelor's of applied science in agrotechnology entrepreneurship. And we thank him this morning for willingly presenting and sharing his expertise in the field of drone technology. Our second presenter is Mr. Cormelo Tommasi. He is the European Commercial and Technical Director at AFuzion Incorporated, Lombardy, Italy. Sorry. He has over 35 years of experience in high technology and industrial marketing, and he's always taking on more responsibilities in that position, from technical sales to marketing and management functions. And he's currently now responsible for the operation as managing director of the European Commercial and Technical Operations.
Yes.
Yes. Our third presenter is Mr. Nehru. He is the chief instructor at Green Tech Aviation. And he graduated in aeronautical engineering. And he has a master's of engineering aeronautics from the Excel Engineering College. He also specializes in drone technology. He has conducted more than 200 workshops and training activities in various educational institutions in India. And he has worked as a technical instructor in research and development on projects to include night vision, agricultural drones, and medicopter drone. He has experience in over 1,500 hours in flying the RC aircrafts and drones. And he was the technical support and test pilot for these drones. Our fourth and last presenter is no other than Dr. Krishnan Umachandran. He's the General Manager Limited India. Dr. Krishnan has over 30 years of experience throughout the value chain to include switch/fuse gears, passenger cars, beverages, pharmaceuticals, medical/surgical devices, foundry, and electricity, only to name a few. He's currently serving as the general manager at Nelcast. Nelcast is the largest gray and SG iron foundry with 3 factories in India. He learns continuously by attempting experimentation, innovation, and networking, and he has personal strengths that include organization building and development with customer-centric leadership and management. And he has a passion for research and has published more than 300 articles. So these are our esteemed presenters for this morning. Just a few housekeeping rules before we start. I will ask you to please mute your mics and only speak during the question and answer period after each presentation, sorry. Each presenter has 30 minutes to present with 5 minutes for question and answer. And we want to keep that time so that we can have an even distribution of the presentations this morning. If you have a question and you would not want to speak in the mic, you can type it in the questions. Also keep your webcams closed. That helps with the bandwidth. And remember to keep your mics mute to avoid any distractions during the presentations, because sometimes we would get feedback and that interrupts the presenter. So if Mr. Nehru here, is he here? Are you here, Mr. Nehru? That's our third presenter. I'm just checking before we begin.
We'll start with Dr. Mohammed Nurfaiz.
Okay, so our first presenter is Dr. Mohammed Nurfaiz, and his topic is drone for rice farming, actual field capacity, operation time and droplet density during aerial fertilizer spraying in rice field. Over to you, Dr. Mohammed. You have 30 minutes to make your presentation. You may share
thank you,
screen.
Dr. Debra.
You're welcome.
Thank you, Dr. Debra, for introduction. And it's an honor to be here. To be present my work. My field in rice farming using drone. And be see with all the experts in the drone fields. Industry. So let me share my presentation slide first. Hopefully everyone can see very
yeah.
And hopefully you guys can hear me very well.
Yes, doctor. Yeah,
that's great. Thank you, Dr. Krishnan. It's an honor to be invited for this workshop, and hopefully it's a benefit for us. Without further ado, I proceed with my topic today. Is drone for rice farming. Where I will cover on the actual field capacity, operation time, and also droplet density. During the aerial fertilizer spraying in rice field. So basically, these my studies are focusing on the using fertilizer, aerial spraying in the rice field instead of pesticide or any crop protection inputs, because there are different result they came out with different tools in the pesticide and crop protection inputs with the fertilizers. Before that, I give some a little bit introduction about drone tech right now. The revolution is currently happening. It's one of a new mechanization. For agriculture. It's booming right now, and approximately about 1.2 billion USD. The last 2020. And expected to reach 5.7 billion coming 2025. solely for drone-based technology, also precision farming. And the precision farming, I think, has been used for nearly about 20 or 30 years ago. And maybe perhaps I think the technology wise is ready, okay, to be implemented widely in the farmings. Where the precision farming, the theory and principle have been introduced from previous, okay, and been adopted, but there are limitation and challenging in terms of technology wise. I believe that the technology right now is I say the right moment, okay, to be used the high tech technology within the farmings. In fact, the labor, okay, the task, the people working, the agriculture itself have been, taught very well in terms of agriculture, also engineering wise. Okay. So precision farming basically is a help farmers, okay, to manage the crop in large areas, where we try to manage those, their farm in the right location, in the right rate, also in the right times. It's a very important um, principle for precision farming. But it help in terms of monitoring and surveillance, okay. And for area mapping, okay, where area mapping is one of the basic and also fundamental within the precision farming itself, and also input application. So precision farming is a practice, best practice, okay. We try to apply the every inputs in the right manners, okay, the right location, the right rate, also in the right time for any pesticide, okay, herbicides or fertilizer, or in fact for seedling, okay, and also irrigations. And right now they have a huge drone being built, okay, that can carry up to 20 kilogram or 30 kilograms, okay, of head payloads. So there are no limit anymore for the drone, okay, compared to the last 10 years, I think. Okay. And precision farming, you have in terms of efficiency, okay, crop productivity, the quality, and also reduce the transport, okay, beyond the edge of the field, where farming they involve a large areas, okay. So drone help in those to fight those obstacles and then those challenges. Today, precision farming have utilized modern technology very well, okay, especially for the area spraying, okay, and the technology keep enhancing and believe that, okay. And in fact, in the rice farming is one of the in my own country, it's become a next generation, important mechanization, where I think it's believed that around 10 hectares they have a service provider, okay, that cover about 100 hectares for the farmers. So for example, like the last project that I've done for that covering 4,000 hectares of rice field, there are about 30 service provider. However, it's not yet enough to cover all those land area where the farmers still have a high demand using drones to cover for their activities. So drone function, I think I have an application. Okay, this is one of drone function as application where I would like to share. Okay, again the crop monitoring. Okay, crop helps and also identify what's happening in the fields. Okay, for best monitoring. Soil assessment right now they also have a surveying. Okay, they have been using a lot of sensors to extract information of the soil characteristic. Okay, for the soil prediction, okay, the soil fertility for precise fertilizer applications. And then we also for the plant images, okay, determine the population, okay, what was called the plant density inside of the fields. And then we're planning for precise harvesting. When the uniform harvesting process is very crucial so that it help further in the scheduling of the harvesting process and prevent any delaying, okay, during the agriculture activities. So it's a help further in terms of transferring the and then harvest the crops from the field to the markets. Okay. Crop protection and fertility, of course, yes. Okay, one of the fundamental application for the using drones. And right now, been a lot of companies that covers using insurance for the rice field. Okay, and they use this drone as part of mitigation or planning process in covering the crop losses for any disaster, especially right now my country have also problem with the cyclone, also have heavy rain right now. So insurance they're using the drone in predicting what the crop being lost and so on, for helping farmers to cover their losses. Last but not least, irrigation, also drainage, okay, as part of monitoring, and so also irrigation predictions for the rice field. So this is a benefit using drone, okay, especially for the smart farming, also precision farming, perhaps in terms of water and fertilizer efficiency, in terms of where we predict, or actually actual crops that require, okay, at the field level. So there are a lot of methods and also modeling being developed, where actually the crops require the precise water and also fertilizer. So using drone, we predict pre and post, okay, basically the activities to predict, and then we apply the water and the right fertilizer and also water to the crops. Save time, increase yield, yes. Yeah, so the mapping, and so last but not least, save money for the long, the long periods. Okay. So crop health assessment, okay, one of the crucial activities. A lot of service provider right now, okay, a lot of company, a lot of startups, okay, they come up with these crop health services that are using drone as part of the activities. Okay, so that's one of the important application using drones for the smart farming or precision farming. Historically, okay, UAV start in the Japan, okay, I think 1990s, okay, where the Japan using these RMX helicopters. Okay, they covers in Japan similar to our countries for the rice farming, where we have small areas, small scale farmers, cover about 1.5 hectares. Okay, compared to the US large area, I think using flight is much efficient compared to drone. And then RMX, they have 4 gallons, okay, and 300 plus average tank size for modern AG aircraft. So the RMX basically they can spray 50 miles per hour, okay, compared to the 160 mile for AG aircraft. So compared with the Japan, they only have small scale acreage for rice field. They're using the RMX widely, but they have problems where I think the Japan company itself, it doesn't. I mean, the government itself doesn't. The RMX come up from their countries. I think that's why it's going down. And the China, I think go seek. I mean, covering the markets in terms of drone technologies. I think There are types of UAV. Okay, there are single rotors. Okay, multi rotors, fixed wings, and also hybrid types of multi rotor plus fixed wing is called VTOL. Okay, so each of these type of UAV, they have their own specialization. Okay, for application. Okay, for agriculture activities. Okay? Where basically single rotors, okay, they can use for spraying, and also for the small areas of spraying, fixed wing for mapping, surveying, and monitoring. Okay, and then multi-rotor, okay, basically use a more a stable one for accurate and precise spraying. Hybrid, okay, multi-rotor and fixed wing, okay, also have a multi specialization, multi features, okay, for activity in agriculture. So for me, you can see that the comparison between those type of UAV, okay, in terms of the altitudes, okay, contour range, and so a speed, okay, and we can say that multi-rotors, where right now GI grass, they can altitude up to 2 kilometers, the range, okay, to cover about 5 kilometers, okay, and a speed about 7 meters per second. While fixed wing, okay, the altitude about 0.125 kilometers, they can control about 2 kilometers, and a speed is much faster, okay, 18.8. While single rotor, only the altitude 3 kilometers, control range about 30, and speed about 15.2. However, for the fixed wing, okay, which is a VTOL one, okay, altitude is up 4 kilometers, okay, much higher, okay, and control range about up to 1,000 kilometers, and speed about 30 kilometers per second. So this VTOL is much better in terms. However, if your farm is huge acres, okay, VTOL is maybe the right choice, okay. However, depends, okay, your budgets, okay, your I mean your skilled workers, okay, they can operate those depending, okay. It's not everything or all farms, okay, can use similar drones. So this one is a DJI grass, okay, basically being used, okay, for my research and also field activities, okay. So this one 15 liters, okay, UAV, okay. They can use for crop protection inputs and so fertilizer. Basically, for my research, I focusing on the fertilizer to understand, okay, what actually the best features, best characteristic or parameters that can be used for application in the rice field. So this one is a mapping that I basically use, okay, Phantom 4 Pro, okay. A lot of navigation system, advanced navigation system, okay, with the combined infrared system is much better. And then with the right now sensors, mini sensors that can be attached to the drones, I have further, okay, to improve on this monitoring and on the mapping and so on, in terms of precision and smart farming for the rice field. Where right now their cameras are RBG, okay, RGB, NR, multispectral, hyperspectral, thermal. In fact, right now LiDAR also have a very cheap, okay, cheap LiDAR, small LiDAR, okay, from China, okay, can be attached to the drones. Okay, in fact, you can have further, okay, and using for agriculture activities. So in my country, basically, UAV solely used for the pesticide application, for crop input application. They are less focusing using fertilizer. So maybe the reason, maybe the problems why the farmers, why the service provider not focusing on using fertilizer. So I will try to answer those question problems. Okay, why the service provider company don't use it. Okay, fertilizer. Okay, for the rice field activities. So all these technologies, again, in fact, right now they are granular tanks, okay, 8 liters to 16 liters, okay, where last a few years ago, we only use a 4 area spraying, but right now we can use granular, okay, which is a granular fertilizer, okay, using with drone to spray or not spray, to broadcast on top of the rice field, which is very, very important because rice plantation actually require granular as part of its fertilizer management, fertilizer regimes. And part of that, my study also using the electrostatic valve, okay, where it improve further in terms of prevent diffusion, droplet disperse, okay, further from the targets, okay. So actually valve is very, very important, can be implemented within the drones, okay. So this one is the studies that I've done in the rice field, okay, in the UPM, okay, in Malaysia last time again. So using the material rotor propeller, okay. So we maintain the height constant around 2 meters from the canopy of the rice field, and then we fly those UAV, okay, drone at three different flying speed. 2 meter per second, 4 meter per second, or 6 meter per second. And then we have 3 replication. And then we have 4 different, spray rate, okay, to spray the fertilizer on top of the rice field canopy. So, okay, this is a schematic diagram, okay, for the site layout. We capture images and so on. We capture everything, parameters at the field so that we don't miss any detailed information. So this one is a spraying pattern analysis of the result from the experiment, okay, for the studies. Where, okay, we found that the droplet deposition density based on the UAV spray rate, okay, liter per minute, okay. I think 2 meter per second have the highest, okay, numbers of droplet deposition densities compared to other flying speed, okay. So 3 liter per minute is I think the best one, okay, if you're flying at a UAV at a 2 meter per second compared to the 4 or 6 meter per second. However, okay, as we do the coefficient of variation, we found that, okay, if you like to fly your UAV, okay, at a 6 meter per second, you should only, okay, spray at around 1 liter per minute only, so that you can get a better deposition density during your UAV flyings, okay. But it's recommended for the rice field, okay, to get the highest numbers of droplet deposition density, and also less droplet dispersion or droplet not that reach to the accurate targets. 2 meter per second is the best one with a 3 liter per minute. Okay. So the final result, we found that, okay, the best spraying rate, also UAV speed, okay, while we doing the activities, wind speed we need to meter at around 1 or 2 2 meter per second only. And then 2 meter above a rice canopy is the best one. Okay, further than that, okay, the droplet will be dispersed much further. And then we record that they can go up to 500 meters. Okay, the droplet dispersed. Okay, and then the spray I again say that 2 meter per second is the best one. Okay, with a 3 liter per minute for the spraying on top of the rice field for the fertilizer one. And then we all do the what's called the variable rate application and also uniform rate application using two different fertilizer, inorganic also organic one. From our experiment, we found that the variable rate application is much faster compared to the uniform one, where uniform is a conventional method. We're using a high, liquids, okay, compared to these variable rate applications. So that's why the variable rate application is much faster compared to the uniform one. And while the organic liquid is take highest, further speed, second compared to the inorganic one, because the organic is the concentration is much lesser compared to the inorganic one. That's why this require more liquid compared to the inorganic. So that's why it's more timing required to complete 1.2 hectares for rice field spraying. And then part of that, we also done the what's called UAV field capacity, operation time, also number of battery to understand further numbers of batteries that require during the field operation for 1.2 hectares, and then the actual field capacity and operation time, so that we can timing and monitoring, so that we can provide beneficial information for the service provider. So this one of the table for the experiment. The volume basically, this one. And then we maintain 2 meter above, from the rice canopy. This the what's called equation that we use to calculate the field capacity. So this one is a result total time recorded for UAV and spraying operation for different treatments. From here we can see that variable rate application for inorganic one is much faster to complete 1.2 hectares. Sorry, the area one is 15 day 80 is basically is the growth stages of these rice crops. So 15 day after transplanting, we record for we do the activities for 5 times until the crops harvest. 75 day 80 is mean 75 day after transplanting, around 20 days before we harvest the crops. So we do this one, and then we found that the variable rate application is much faster compared to the uniform one, and organic also is is the average compared to uniform. However, the uniform still the highest. Take more time to complete 1.2 hectares for the UAV and spraying. The reason is why, because they are significantly different because to the volume of liquid for each of the treatments, and then uniform require much numbers. So volume of fertilizer being recommended by the supplier. So that's why it should take more time to complete. While variable rate, we do the site-specific nutrient management, where we calculate the precise fertilizer based on the actual crops needed. Where we have our own modeling, for the based on the coffee contents, and then we calculate from our modeling stuff, and then get the numbers of the fertilizer, and then we supply those the accurate the fertilizer to the crop using the UAV. So it shows that variable in organics is much better compared to the uniform and also organics. But this one in terms of total time recorded. And then the UAV time refilling frequency we also recorded. What's the numbers they require to for numbers of refilling, because refilling is also one of these tedious job that need to be done by the supplier. I think this is because the reason why the most of the service provider for the drones, they don't implement the fertilizer activity, because now there are high frequency of refilling process to complete 1.2 hectares. For example, like this one, for uniform one, you can see that the 12 times to refill tanks during the activities, one time only. One time for 1.2 hectares, 12 times they need to refill compare for the uniform treatments. And then for the variable rate application, they take less time to refill. They only about two times only to refill the tanks. And then do you see that 35 DAT and 55 DAT is very high for the variable rate organic? Is because during this period, organic fertilizer being supplied highest compared to these other treatments. So because the volume, the concentration rate of the organic one is lesser compared to the inorganic fertilizer. That's the reason why. So that's why we need to understand that, so that we can have further service provider can at least they get this information, then apply beneficially to the field, help the farmers implement.
Dr. Fayaz, you have 5 more minutes.
Okay, sure, I will finish it. And then the last one is a battery changes frequency. Okay, see the uniform one still the highest, okay, compared to the variable rate application. Variable rate application only takes about one batteries frequency. It's about the battery last time we used about 2 set of battery take about 15 to 20 minutes to complete 1.2 hectares. However, for the uniform one, since the volume is higher, they take about 3 times frequency. Okay, I mean 6 sets of battery, to be changes during the fertilizer application activities. This information is very, very beneficial, as I've been give this information to the service provider. They said it's very helpful, and they try their best, okay, so that they can provide fertilizer management for the farmers in the futures for the rice field. So you got the field capacity again, okay. Variable rate application is the better one, okay, compared to the other treatments. Uniform, okay, is the lowest one again, okay, compared to the variable inorganic. This is in terms of field capacities. Okay. So in conclusion, I can say that field capacity is a vary according to the different treatments that we apply. And then variable rate fertilizer, okay, show higher field capacity, faster in the flying time, less refilling process, and use less battery set compared to the other treatment for the fertilizer activity in the rice field. Overall, volume of liquid basically it affects the total area spraying process. Okay. So from our study, we found that variable application had further, okay, in terms of fertilizer application using drones in the field activities. I think that's all for me. I only had example in case study. Maybe in enough time, you have time you share. We get back to the Dr. Deborah. Any questions?
Thank you.
Thank you. Thank you, Dr. Faiz. The floor is now open for questions from the participants. You may open your mic or put your hand up and we'll allow you to speak, or you can type your question in the chat and I will repeat it for Dr. Faiz. Okay, Dr. Faiz, I would like to ask, how do the ordinary farmer, we're not talking about big production here, access this smart farming technology? Do they undergo training? Do you offer training? And in terms of the equipment, is there a package that is offered to the rice farmers for the smart farming, that they can acquire at a reasonable cost and so on? How do they actually access the technology to learn how to use it and to benefit from it in smart farming, especially in rice farming?
Thank you, Dr. Reba. It's a good question. Okay, where right now, service provider, okay, in Malaysia, basically, these emerging technologies being it's a privatized, okay, it's a service provider being, not monopoly, but again, it's a business opportunity for anyone who interests to pursue in terms of drone technologies in the rice farming. Okay, so in Malaysia, okay, the trend is very positive. Okay, is very positive where the youngster, basically they're interested to pursue in the farming, but using the technologies. Drone is one of the example that the youngster pursue in Malaysia. So the way the business model being used in Malaysia is that service provider are the one try to teach, give awareness, and then provide the best services with a affordable fee to the farmers. And surprisingly that farmers rice field in Malaysia is some place that I working right now. uh in fact, I'll do the survey, okay, among the farmers, around hundreds of farmers, okay, the rice farmers. Okay, they're very interested to using the drones as part of their mechanization, as part of the activity. In fact, they are willingly to learn this technology. Only the main problem is that, the major challenges is that the farmers, uh, in terms of the fee. Last time, I think 5 years ago, okay, we already start the drone technology for the rice farming. They charge 1 hectares around USD 25. Okay, for farmers in Malaysia is very expensive. Okay, but today, okay, the price decreased dramatically because of there are high numbers of service provider coming out after the COVID one. After the COVID period, the numbers of service provider, okay, are increasing. So the numbers of fee are dramatically reduced. Right now, they're around I think about $4 USD for 1 hectares. So that's why the farmers, rice farmers in Malaysia, accepting this technology as a new mechanization for their field activities. If you came to Malaysia, you see the rice field, you can see that all the 4WD tractors, tractor trucks and so on, they own UAV behind of that, so they can see that they're spraying, and then they put the seeds, okay, put the seed using the UAV and the drone itself. So there's a good positive that happens right now, where the farmers are accepting at a high value level. So I also in the process of publishing the survey. Okay, all this my study that I've done for the field capacity, and also these droplet density have been published in the computers journals. Okay, so you can refer to it. Okay, maybe I can share in the chatting after this. We can get the articles that have been published and been peer reviewed, so maybe can be as a reference. So in future, maybe we can do the second drone workshop. I can share the survey, okay, from the result that I have done. Okay, a lot of very positive result. Surprisingly, okay, the farmers process of changing. Yeah, maybe the youngster, and then they see the benefit of drones in the rice field activities.
Thank you, Dr. Fias, for that comprehensive response to my question. Are there any Are there any other questions for Dr. Fias? I'm not seeing any in the chat. You may open your mic now. We can take just one question before we move on. Okay, I think there are no other questions at this point. So I want to extend heartfelt thanks to Dr. Faiz for that very insightful presentation on drone for rice farming and giving us these insights into the use and benefits of the drone technology, or UAVs, meaning unmanned aerial. Yeah, unmanned aerial vehicles. That's the other term for drones or UAVs. Thank you, Dr. Faiz. Okay. We will now.
Thank you.
You're welcome. We will now have Mr. Cormelo Tommasi, AFuzion Incorporated. Yes, please. You can now share your presentation on applying DO 178 avionic certification to drones, costs, benefits, and considerations. Over to you, Cormelo.
Thank you again.
Dr. Nurfaiz, you need to. I'll share it. Dr. Deborah.
Yeah.
Let Dr. Nurfaiz remove his unshare.
Yes, please. Dr. Faiz, could you stop sharing so that Dr. Krishnan can share?
Already unshared. Yeah.
Yeah, no problem. Thank you.
Okay.
Thank you.
Okay, just a second.
Can you see Dr. Cormelo Tommasi?
Yes, absolutely. But you should go to slide 1.
Yeah, I've kept you in slide 1 only.
Okay, perfect. Okay, we will talk today about UAV or drones certification, avionic certification. What are the costs? What are the benefits? And general consideration. My name is Cormelo Tommasi, and I am the CTO and for AFuzion in Europe, and we specialize in avionic certification. So not only UAV, but also big aircrafts, big rotorcrafts, and so on and so forth. So we will talk about avionic, how we certify the UAV. Next slide.
Okay.
Okay, the topics will be DO 178C, that is the certification document for not only for general aviation, but also for UAV and UAS. The optimal route to follow in order to certificate the UAV, and we will talk about the UAV and UAS special safety checklist and MCAR. I will talk about all the acronyms, obviously. Then we will have the summary and what do you need to do if you need more information. Next. Okay, this is the glossary. The glossary is important because we have a lot of strange acronym. For example, we don't talk about drones, but UAV and UAS. UAV is unmanned aerial vehicle, and is the part of the drones who flies. UAS means unmanned aerial system, and include the UAV and the ground station to control the UAV. OPA means optionally piloted aircraft. It means an aircraft that can be optionally piloted by a human on board, or can be treated as there is a lot of noise, I don't know why. And it can be optionally piloted by a human on board or not. NAS is the United States National Airspace System. It is very important, the airspace system for every country, because it is the civilian airspace, and we need the special certification for UAV to fly in the national airspace systems. And finally, MCAR is mixed criticality architecture requirements we will talk about, and it means a CPU running application with different criticality. Okay, next. Okay, it is good to if you like to gamble, but please don't gamble with UAV avionic certification, because to have an effective certification, you need to consider careful all the key issues of of the UAS and the UAV. Okay, next. First of all, what is an UAV or UAS? It is civil, it is commercial, it is military or something else. Next. Next. It is an helicopter, it is an airplane, it is large, small, commercial, civil, military. Next. The answer to that is all of the above, because UAS and UAV are all the definitions we said in the previous slides. So we have to first establish a certification basis because we have to tailor a set of industry and governmental airworthiness regulation to those kind of systems for certification. And the big focus, especially for civilian application, like the ones that were named by Mohammed in the previous presentation, is safety of the design, the UAV, for safety of operation. We have to operate safely. Okay, what is the aviation development ecosystem? Those are all the applicable certification documents. We start from the safety guideline, ARP 4761A. They are so you start from safety, then you go to ARP 4754B. That are the guidelines for the system design and development. And then you have all the specialized document. For example, you have DO 178C for airborne software. You have DO 254 for airborne hardware. You have DO 278A for the ground station, so the ground system to control the UAV, and so forth, and so so. Okay, we will try in 3 minutes to have a quick recap of the DO 178C certification. Next. Next. What is DO 178? Is the certification standard for airborne equipment. DO 178 is software. DO 254 is hardware. Is regulated by FAA in US, Federal Aviation Authority, EASA in Europe, European Aviation Safety Agency, DGCA in India, Directory General of Civil Aviation, CAAC in China, Civil Aviation Administration in China. So the names of the document vary. For example, it is DO 178C in USA, ED, European document 12C in Europe, or DE 254 in USA, ED 8 in Europe. So the name changes, but the documents are all the same. The certification consideration for airborne equipment are the same all over the world, and covers the full engineering life cycle of the system. So from planning, configuration management, quality assurance, development, testing, to the development, from requirements to design to implementation, both hardware and software, to testing, verification, all through development, and finally certification. Next, please. what is the evolution of DO 178? The DO 178 was started in 1980s, having as basis some military document like MIL 498 and 2167A. They were only artifacts, document traceability testing. There was no application to UAS. Then you added the process testing, the DO 178A. Then, because of the crash of Lauda Air, 223 casualties, because there was a problem due to integration, it was introduced the DO 178B in 1992, together with transition criteria, development method, data, and tools. And there was no document in the year 95, 2000, and this is the time when the drones became popular. So the certification basis is still DO 178C, B, sorry. Then in 2012, the DO 178C was introduced, reducing subjectivity, addressing modern software technologies like model-based technology, object-oriented technology, and apply to UAV and UAS. Next, please. There are three key processes for DO 178 certification. Planning process comes first, then you have the development process, follows planning, and finally the correctness process that is continuous throughout the project, because you have sorry.
Can you close?
Please go ahead, Cormelo, Tommasi.
Mr. Tommasi, you may continue the presentation.
Okay. So the correctness process, it means validation and verification and testing and the configuration management is all through from planning to development, and it is continuous. Next, please. This is the optimal DO 178 engineering route also for UAV and UAS. You start from safety assessment and the requirements. You start quality assurance for software and PA, process assurance for hardware. You create the system requirements. You develop the plans for UAS and UAV, the standard, the checklist. You develop the traceability from requirement to implementation and implement the configuration management. Then you have the SOI 1, stage of involvement 1 with the certification authority. And you go to high-level UAS requirement, low-level requirement, design, code and logic, integration, and remember the verification and testing. And you have the stage of involvement 2 with the certification authority, talking about if you have created satisfied all the requirements with the implementation. Then you go to SOI 3 and 4. Okay, sorry. Okay, then you have special consideration for UAS. Go next, please. Next, please. Hello. UAS are very, very similar to commercial aircraft, which require 178-254, because they have a complex avionics, they have a complex integration, they have COTS, standard components. As Mohammed said, there are standard sensors in the UAV. So you have landing and takeoff procedure, commercial airspace, and if you have accident, you have civilian death. So for commercial usage, the top priority is safety. For military use, the target is not the safety, but it is success of the mission. And let's say that the civilian certification authority lack common knowledge to apply commercial certification rules. Next, please. So why there is a big demand for 178-254 avionics certification on UAS? Because UAS manufacturer must show safety for flight safety operation, because they have to integrate those systems into civilian airspace, and they should avoid uncontrolled landing in non-military locations. UAS community see the big success that the certification strategy in many avionic company has been reached to have a great reusability of the UAS, higher quality of the avionics, lower MTBF, IMA, redundancy, lower development cost after the first project. So the first certification project maybe it cost twice as a normal development project, but then from the second on you save money. Okay, the next. Some special issue for UAS. What is the criticality level? It is safety, it is mission, it is operation, it is airborne or ground-based. The DO 278 applies to ground-based system certification, and it does play a role. Then a big role is played by FAE Order 8130-34D, certification of UAS. It is a document coming from Federal Aviation Authority in USA, and we will give more details after. And the US Air Force MCAR, Mixed Criticality Architecture Requirements for UAS. We will describe that later. Please, next. So let's talk about FAE Order 8130-34. It was the first document to address UAS, UAV, and was issued in March 2008. And the title of this document was Airworthiness Certification of Unmanned Aircraft System. This order was adapted from a collection of different advisory circular contained in, for example, in FAE Order .2. And the most recent version of this 8130-34 is 8130-34D, with not only for unmanned aircraft system, but also for OPA. Next, please. Now, in the following 9 pages, I have reported a checklist of 8130-34D. If you want to design an UAV, UAS, you should follow this checklist. It is very, very, very useful. And obviously, I will not name point by point all the checklists, but it is very, very interesting for you who want to design an UAV. Next, please. For example, it is divided in segments. For example, airframe described in detail the physical configuration characteristic of the aircraft, including size, weight, and so on and so forth. Next, please. For example, what is the maximum altitude it can reach, the maximum endurance, cruise airspeed, then the propulsion system, describe in detail what is the propulsion system design and also the performance of the propulsion system. Next. Electrical system, described in detail the electrical system, the flight control surface and actuators, and the payload. Describe the payload equipment that is installed in the UAV. Next, please. Okay, those are checklist, design checklist for the command and control segment. So avionics, the navigation, the flight control, and the autopilot system, and the lost link. What happens? For example, you have to describe very, very in detail what happens when you lose the link to the UAV. What happens? Does it falls? Does it softly lands? So should be very, very detailed described. And also the control station, described in detail the control station. Next, please. The ground support equipment, obviously, how is done, and how do you mean to develop the software, the software for both for UAV, so airborne software, and for UAS, the system. Then you have to describe the operation, how the interaction between your UAV, UAS, and the national airspace system. Next. You have to describe all the flight phase, the pre-flight taxi operation, described how all the pre-flight phase happen, and so on and so forth. Next, please. Then operations, again, takeoff, launch, flight, how identify all the flight parameters. Then also the landing, how are the procedure for landing, for safely landing, and the post-flight. What do you do post-flight? Next, please. And all the flight plans, all the operating history, manuals. Have you manuals about the UAV? How are those manuals structured, and so on? Last safety checklist. Then you have organizational consideration. So what is the preparation of pilot crew qualification training? So how do you plan to train the personnel for your UAS, the pilot, the observers? And finally, does a maintenance and inspection program exist? So, as I said, it is a very long 9-page checklist, but it is very, very interesting for you, for people who wants to design a UAS. MCAR is a special concept for UAS, recently extended to other domains. For example, this concept has been extended to automotive, the railways, transportation, and so on. Mixed criticality architecture requirements essentially mean that a CPU runs application with different criticality level. For example, the same chip that controls both flight control procedures and entertainment system. So very different criticality, and has been promulgated by US Air Force. And what is the goal? The goal is the reducing certification work and functional safety decomposition. For the certifiable real-time operating system can ensure isolated task running. And finally, the summary of my presentation. Integration of the US into the NAS and other country is an extremely complex undertaking. Is a complex undertaking because it involves safety of people. It involves people life, casualties. So it is very important. There are several issues need to be resolved before the UAV can freely fly in the airspace system. So the goal is on safety, and R&D of UAVs focused on advanced mitigation of performance shortcoming to facilitate integration in the airspace system. And very important, cybersecurity is becoming an increasingly important factor for USO operation. Okay, if you need additional information, AFuzion can provide safety critical white papers, training, analysis, consulting, and just visit www.afuzion.com, and you can have a free technical UAV white papers, or you can write to me, to carmelo.tommasi@afuzion.com, and make reference to Van Silderman's book, The Aviation Development Ecosystem, that is available on Amazon. And obviously, you can do any kind of question now by writing in the chat or lifting the hand.
Thank you, Cormelo Tommasi, for enlightening us on the requirements for DO 178 avionic certification for drones. We will now open the floor for your questions.
Yeah.
You may type in the chat or raise your hand, or you can open your mic.
Or you can write to me, or you can visit afuzion.com. There are many of you that design drones or UAV or UAS.
And that's a question for the audience participants.
Yes.
Yes. Do you design drones? How many of you, or have you attempted it? Okay. In the meantime, Cormelo, is there a requirement where you have to actually get approval for your design before you actually develop and then apply for certification?
Okay, not before. You have to apply the DO 178. If you remember my slide with the green snake, you have to first of all, okay, you have to decide. I want to design a UAV for civil application, like a UAV for agricultural application, as we saw in the previous presentation. Then you have to not first to design the system and then apply the certification. You have to planning your design, as I showed you in the green snake, in that green snake slide. So you have, first of all, to create the plan. So to describe what you want to, if you want to be certified, you have to plan in advance what you want to design. You have to plan in advance how, what tools you will use. You have to plan in advance your requirements. You have to write very precise system requirements, and then create your configuration management. And then you can start to implement the system, but you have to plan in advance. So you cannot first design something and then say, okay, now I want to certify it. No, does not work like that. You have to certify, to start the certification plan since the beginning, since you have the concept in your mind.
Okay. Thank you. Yes. So you must get the plans approved.
Exactly.
Before,
because
yeah.
if you remember the small yellow box SOI1, it is a moment in which the certification authority, could be the FAA in USA, EASA in Europe. It is the moment in which when the certification authority checks if your plans are safe. So it is the moment when they certify your planning. And then there are other SOI 2, 3, 4, when the certification authority checks what you are doing, how you are designing, how you are implementing your UAV. But there is also the check of the plans in advance.
Yes. So thank you for that clarification, Cormelo. We have two questions in the chat. The first one is, what would be an advantage or benefit to consider in using the drones, in particular the certification and the actual use and application?
Sorry, I can't understand the question. So
okay, so is there an advantage or a benefit to having the drones certified for use?
Oh yes, absolutely, because even if you run a UAV in the country for agricultural application, you have to certify it, because if you don't certify it, the drone can drop and cause casualties. It is very important that obviously the certification of a Boeing 737 is different from the certification of an UAV. Obviously, it is much more difficult to certify a Boeing 737. But you have all the way to certify an UAV for flying it in the civilian airspace. You must certify it, but it is not the user problem. It is a problem of the manufacturers. So the manufacturer must certify the UAV, not the user, obviously.
Understood. And this is the last question. Is there any concern regarding environmental or health issues in the use of drones?
Absolutely, absolutely. There are all the I talked about DO 178, but there is another document called DO 160 that is a document that deals with environmental conditions and so an UAV that has to fly in Alaska is different from an UAV that runs in I don't know, in Central Africa. It is very different because you have to consider the harsh environment condition, and this is specified in a document called DO 160 that is named in my presentation. I think the presentation will be delivered to people. Yes,
yes, it would be. All right, so we have one quick question, but it's very comprehensive, so I don't think you'd be able to respond in this time, but I will still ask it. How do you go about creating a certification body in a country? And you may you may put a resource link
that's
in
very
the
good.
chat.
No,
yeah.
It is a very good. It is a very good question, because we had the experience as AFuzion to create in China the certification authority. So it is very easy. First of all, must be an agency from the government, so at a very high level. So it cannot be a private company. It must be paid and sponsored by the government, first of all. And second, okay, the government decide to create a certification agency, and then they, I don't know, hire 20, 30 people, I don't know. And those people must be trained. For example, we have trained all the Chinese people that have formed the Chinese certification authority. You have to train, and normally, as I said, those people take as the certification document, the certification document from Europe, EASA, or from US, DO 178. Maybe they change name, but they use those documents.
Okay.
And, okay.
Yeah, thank you so much for sharing that insight. Can I ask you, Cormelo, to put your contact or email in the chat, so that the person who asked that's one of my students can follow up with you.
Well, it is in my presentation, so if you deliver the presentation,
so thank you.
In the last page, there is my
contact.
email.
Okay, so we'll get it from there. So thank you very much for that very comprehensive presentation on the requirements for drone or UVA certification for the aviation industry. And
okay,
thank
you very much. Bye-bye.
Bye-bye. You're most welcome. And we'll move right into our next presentation by Mr. Nehru. He's the Chief Instructor at Green Tech Aviation India, and his presentation is entitled Powerplants for Drones. Over to you, Mr. Nehru. You can share your presentation. You have 30 minutes to present, and we'll have a 5-minute question and answer to follow.
Yes, thank you, Debra ma'am. Is my audio and presentation is visible?
Yes,
yes, Nehru.
So first of all, myself, Nehru from Green Tech Aviation. I think all the intro is already done. So I thank Krishnan sir for getting me into this webinar. So in this webinar, I'm going to tell you the things about our company and what are the things we are doing in the field of drones and some general information of how the drones are powered nowadays. So that will be in my topic. So for that, I'll be going into my activities. So these are some of the activities that we are doing in our country on behalf of our company for the students to learn about drones from 2016 itself. So more than 6 years we are in the field. We are basically an aero modelers. So aero modelers in the sense we will be making aircrafts. So from 2016 in India, the drones are introduced with a basic flight controller. So we have been introducing to them how to fly, how to make. So these are some of the pics of those activities like water rocketry for the school students and air shows we'll be doing with aircrafts. So these are the things that we are done before the drones came into the field of action. So nowadays drones came into a lot of fields like already we have discussed a lot of fields. So and nowadays we are doing agriculture drones for the customers, like we'll be importing the components on some of the frames we are making in our house, and we are selling it to clients. So we have aero modeling workshops for telling them students how to make an aircraft and what are the tricks in doing that. Like flying an RC aircraft is different from seeing itself. Okay, so our hands and eye coordination should be there. So for that we are doing some workshops in colleges. So we'll be conducting drone workshops for the engineering students also. So in that we'll be telling them how to program the drones, like programming in the sense how to set the values. Like there are two types of flight controllers available in the market. One is open source and it's closed source. Closed source is something like DJI drones. DJI drones I think already discussed here. So that flight controllers will not allow you to change the basic parameters. You can configure it to any frames like quadcopter or octocopter, whatever the frames you can do. But the thing is, basic parameters you can't change. So we'll be using some flight controllers like Pixoc. So Pixoc is a worldwide, it is available. So that is an open source platform. So we can change basic values also, and we can reprogram it. So like that, we'll be training them students for doing those things. So these are some RC aircraft workshop pictures, like from balsa wood, you have to how to listen the plan, how to getting out a product from a blueprint. So all those things we'll be training them, and we'll be training them how to fly this also. A basic flying training we'll be giving. So these are some air shows. So we have a lot of aircrafts in our office. So like with IC engine powered, electric powered gliders, even aerobatic models, a lot of things we have. Even control line also we have. That is the most important hobby in foreign countries. Like they'll be using small IC engines to power their aircrafts to fly. So these are the things that come before drones, because control lines were there more than before, like 40 years before it was there. So these are some big aircraft we'll be doing, and we'll be telling them to, like aero sports also we'll be doing. So taking the students into hot air balloons, so for the joy rides and all. So up to there, these are a simple introduction of a company. Like these are the activities that we'll be doing. So after that, we have the main topic that we are in the discussion, that is drones. So basically we'll be using drone for these are the activities like performing a mission. Initially, it was done for surveillance. By using a camera, we'll be using it for surveillance purpose. After that, we are considering it as a vehicle. So vehicle can be used for any different purpose based on its size. So if you are using small size vehicle, it will be used for camera. If it is using for big size vehicle, it is used for payloads. For example, it is an agri payloads like 10 liter, 10 kg capacity payloads, and VTOL is there, that is for more than 15 kgs, even 1 kg payload. If you want to go for long range, then we'll be switching it to aircraft. So it is a combined platform. So like that, the drones are introduced. So on powering the drones, mostly will be powered with a BLDC motor. So the motors are relied on only the batteries. So we have nowadays we have some batteries that are highly efficient, but the thing is there are alternate sources came into the field. So general problem with batteries is these are the ones. Okay. So we'll consider the battery limitations and all after on the further slides. So these are the known powered sources right now in the field for powering the drones. First one is your batteries, already we discussed. And next one is your solar power panels. So in fixed wings, it is mostly useful. In case of multi-rotors, it is actually not possible one, because panels are not providing high density power. You can provide voltage, like if it is a 12 volt power drone, the panels are available in the market, but it is not enough to power the entire drone with a high efficient, like for example, you can tell if you want 5 amps current or 30 amps current in a panel, no, it is not possible, but you can get the voltage. If you want bigger amps, you need a bigger panel, so there is no space for that, and aerodynamically it is not suitable for fixing solar panels in a multi-rotor. So in case of fixed wing, you can have, so I have a slide for this also. And next one power source is hydrogen fuel cell. So that is an alternate power source that is coming in the field from past 4 years. I have been, while I was in learning these things, in that time also it was there. Nowadays, a small hydrogen fuel cell is there. Based on the drone size, we can customize it. So our next one is laser transmitter. This is a very new technology for powering the drone, that is wireless, like wireless charging. It is one of the method to give power to the drone, the flying drone, without any wires. Okay, and next one is your hybrid engine. That is a topic of my day. So I'll be concentrating on this hybrid drones by today. Okay. So in case of batteries, we'll be using lithium polymer batteries for our drones mostly. So polymer batteries generally in the capacity of 30,000 mAh or 16,000 mAh. We'll be using for our agri drones 16,000 mAh batteries we are using. So, but whatever the mAh I'm using, I will be getting only 20 to 25 minutes of flight time. If I'm increasing 20,000 mAh battery instead of 16,000, even then also I will be getting only 2 or 3 minutes higher. This is because the weight of the battery. So we need to work on that. So that is why batteries is having some limitations. So for choosing a lipo battery, if you are doing a project or doing something, if you are making your own drone, or if you want to choose a battery for your drone, you can use some simple calculations like so generally a battery is defined with these 3 parameters. So what is the voltage of your battery? That means cell voltage. Each generally the lipo battery is having cells. Each cell will be lithium polymer cell having 3.7 volt. So if you are using a 4 cell battery, it will be 3.7 into 4, just absolutely 14.8 voltage. So not only the voltage is a limit, so we have to concentrate on discharge rate. Discharge rate is nothing but it is a measure how much time that battery can safely discharge this voltage. That is C rating. Mostly it is a C rating. So if you want a higher power like racing drones or FPV drones, you have to switch for higher C rating batteries. If you are going for fixed wing aircrafts like gliders or simply a camera payload fixed wing, you don't need a higher C rating batteries. You can go up to 20 or 25 C batteries is enough. So because you don't want to carry higher weight in that, because if your C rating is higher, your battery will be a little bit bulky. So our next one is capacity. It is already, if your capacity of your battery is higher, it is absolutely the terms of timing. So if it is 1300 mAh, it is giving like 5 to 10 minutes for your glider. So if it is 3000 mAh, the timing will be higher. In case of fixed wing, it is a more and more advantage. If in case of multi-rotor, I told you the batteries will be a little bit bulky. So that is an issue. So these two formulas mainly used to calculate the for choosing the battery. One is battery capacity watt hour. So what type of mAh you need now, you have to calculate based on this battery timing. So the sigma is your energy density and E is your capacity, and next one is your mass. Mass in terms of weight. Okay. So flight time, if you want to have a better flight time, you need to optimize the battery selection. So battery selection should be very, very optimized to have a better flight time. So that is to be concentrated by choosing some basic formulas. Even without going to much aerodynamics for the drones, you can have a lot of online calculators available in the market like Prof calc and Omni calculator. A lot of things are available in the market. So with that, you can make some simple calculations like iterations. You have to make some initial calculations and then you have to update it, because if your calculation is wrong now, you have to change your assumption to make it a better optimization. Once you are optimized, then you can go for a production lineup. So this slide already we discussed on that. So we have certain limitations in the battery. As I already told, if you are going with low energy density batteries, then absolutely you don't have enough power to take off your model. So mostly agri drones powered with 100 kV or 340 kV motors based on the configuration. If it is a hexacopter, the kV will be higher, and if it is a quadcopter for the same capacity, the kV will be lower. The term is already known. If your kV rating is higher, the RPM is higher, and if your kV rating is very, very less, means RPM is less, but the torque is higher. So in that term, we'll be having the battery. So generally the batteries takes a long charging time. For example, we are using a 16,000 mAh battery. So that is taking nearly 35 to 40 minutes with 14 amps of current. So if I increase current amps, it can charge at less time, but the cycles will be decreased soon. So you have to charge your batteries at less amps, mostly up to 10 amps or 8 amps you can charge, but it takes even more, consume more time. So and short endurance. Most of the batteries will give only 15 to 20 minutes, and the camera drones right now available in the market are giving 30 to 45 minutes. That is ready-made drones, okay, with DJ or 3D or whatever it is only giving 35 to 40 minutes. That is a maximum is achieved. So batteries are a little bit heavy based on the capacity, already is discussed. So, and we have the next power source is solar power. Solar power is already, I told you, with a panel, you will be generating an energy. So, and we'll be using a battery also in this system. So panel is giving the continuous current for charging the battery, and batteries will be responsible for the entire flying. That is one option. And one is backup power. With the panel voltage will be directly powering the drones, but if sunlight is somewhere it is lesser capacity, then the drone will not have enough voltage. At the time, the battery is used as a backup power to power the drone. So these are some of the images that we have already done some projects on the solar powered UAVs for the students or R&D institutions. So we'll be fixing some panels in array. So we'll be connecting them in series. So you will have voltage higher, and if it is a parallel, you have the arms will be higher and the voltage will be the same. If it is a 12-volt panel, like 100 panels, if I'm using the panel net voltage will be only 12, and I'm having a higher arm, so I can power my motor. So these are the, if you have higher wing space and wing area, you can make panels. You can use the solar power. So if it is not there, we can't switch to the solar panels. But nowadays, a lot of other panels also in the market, so we can switch over for that. So, and one more thing is hydrogen fuel cell. So it is mostly a silent one, so it doesn't make any direct pollution to the environment, and it is not a sound like if you are going with hybrid drones, it is powered with an internal combustion engine, so it will produce some noise. So that is a problem for the environment. So in case of that hydrogen fuel cell, it is not producing much sound. So it is a powerful source, and you have only hydrogen reacting with the ambient air, so making the power source. So we have some power modules for that. You have to use your cylinders. I think the cylinder is there in the photo. So with this hydrogen cylinders, the gas will be going to the power modules. That is fuel cell power module is there. A lot of things are available in the market. So even Yamaha also trying to do that. So the research is ongoing. So if it is done, so you will be having like your CNG cars, you can make this also, and having lot like putting in gasoline for the hybrid drone, so you can make changing the cylinders. Okay. So the main advantage of this hydrogen fuel cell is you can quickly refuel, and otherwise you can swap out the cylinder. So if you have alternate cylinders with you, once the cylinder is empty, you can easily swap it out. So size can be specified. It is nothing but if your drone is a camera drone, you can have a small tank with a small capacity. And if you are using for what is that agri drones, it is a bigger one, and it has a payload capacity of 10 kg. So in that case, you can have bigger cylinders. So it is a vibration free environment. To mostly IC engines will produce vibrations while running. So this type of hydrogen cell engines will not produce that much of vibrations, because for camera payloads the vibrations should not be there. Even the gimbal is there, the vibrations, if it is less, now it is an advantage. So one more powering system is tethered. Tethered is nothing but we will be giving power to your drone from the ground. So the main disadvantage with the system is the limitation. So mostly it can go up to 300 meters height, but you can't go the circular range. It is not a 300-kilometer range. It is a 300-kilometer height. So what is 300 meters height? So you can use it as a temporary communication tower. Otherwise, you can use it in what is a traffic signal monitoring. You can use, and for temporary surveillance areas inside the forest, if you are going, we can use it as a communication tower to get a satellite communication to the local surroundings. So like that, we can use tether drones, because if you want long endurance or unlimited endurance, you can use tether drones in this case. And then I think the photo is a DJI Matrix M300. So it can also powered with a tethered system. So you need a special system for that, because the winder should be able to identify the tension that is required from the drone. Because if the drone wants to go higher, the tension is felt in the winder, so it will release the wire. So if it is coming down, based on the tension sensor, it is automatically rewinded again. So like that, the systems is there. So, and next one is the laser transmitter. I told you it is a wireless, like a wireless thing. So mostly it is having two systems. One is a transmitter and one is a receiver. So laser receiver will be there, and transmitter is there. So we'll be sending a laser light to the laser receiver, that is flying like flying ship. I think you have seen, or flying fixed wing aircrafts. You can easily do that. Even multi-rotor also research is ongoing. So beam of light is converted like our solar power. It is a concentrated beam of light. So it is converted into energy with the from the receiver, the laser receiver that is fixed in the drone. So you have a picture here. So I'm giving an input of 4000 watts. So the laser will be giving a DC input 3600 watts. So beam power is only 2000 watts. So delivered DC is 1000. So our achievement is easily get from this, but it is something dangerous system. So only in line of sight you can do this. If a drone is very long, you cannot do this, because if it is out of sight or with some obstacles, it is difficult to send the power. But it is also a like tethered system. It is somewhat updated version. So that is the one. So next one is our main topic of hybrid drones. So hybrid propulsion, why I'm taking is a main topic means we are already in the field. We are selling to customers for the hybrid drones, and we are servicing it, and that is why mostly we concentrated on this topic. So hybrid propulsion system will be having two power sources. One is the battery and one is the engine. So that process will give you high efficiency and extended flight time. Mostly agri drones with a battery powered. So if I'm using a 16,000 mAh battery, I'll be getting 1 to 2 tanks per battery cycle. So if I want some more tanks, I can't go. So with this hybrid drones that we are doing right now, it is giving 45 minutes of flight time with 3.5 liters of fuel tank. So that is a main advantage for our clients, because clients don't need to buy extra batteries with them, and if the battery life cycle is also limited, like 300 cycles company is giving, so if it is going less than that, or after 300 cycles, what to do? The battery has to be thrown up and we have to buy a new battery. So that is why we'll be going for this hybrid systems. So reduced energy consumption rates. So without degrading your flight performance, you can have a high and efficient system. So in case of weight, I'm telling, so it is a changeable weight, like in our aircrafts, while I'm flying, the fuel is consumption and fuel is gone there. So weight will be decreased and your performance is also increased. That is the point I have mentioned in the slide. So in case of gasoline, while I'm flying, the weight I'm losing. So like 3.5 liter, na, it is 3.5 kg of weight. So while I'm flying for 1 hour, na, like 10 minutes I'm flying, I will be losing 1 liter of fuel. So 1 kg of weight is also lost there. Even pesticide is also I'm losing. So that is why this efficient. So redeployment is also easily done while filling the pesticide, like 16 liter of tank we are using. So while filling that, we can easily refill the petrol also, like gasoline also. So hybridization, already I told you, it is a combination of internal combustion engine, otherwise a gas turbine engine we'll be using. So mostly we are into the field of internal combustion engine. Mostly in depth, I'm telling you, it is a two-stroke engine. Two-stroke engine we'll be using in this our hybrid drones. So it is not a direct drive. So engine will be using as a generator. So generator means the engine mechanical, that is engine is converting the chemical energy into the mechanical power. So the mechanical energy is converted into electrical power with the help of a starter generator. So that generator will produce the required power for the system. For example, the generator is can be powered up to 6 kV. So 6 kilowatt of power is produced from the generator. Mostly we'll be using that type of gensets only. We have 7 kV also is there. So currently we are using 6 kV gensets for that. So engines is a 100 cc engine, 100 to 120 cc engine we are using here. So with that generator, it is keep on charging the batteries, and also the entire drone systems like flight controllers and your motors, everything is powered with the energy, because all are interlinked, like engine power is interlinked with the battery, and flight controller and motors, everything is interlinked. So with this interlink, if any power drop is there from the engine, the battery will immediately come into action and give the required power for the flight. Like if the fuel is empty and engine is turned off, the battery will be used as an emergency backup. And sometimes engine is clogged with some dust and engine is not producing enough RPM, then that time also the battery power is used. So this is a critical layout of the total hybrid system that we are using now. So in this, we'll be having a quadcopter layout. So that is why 4 brushless motors there. So 4 brushless motor absolutely require the 4 ESCs there. So with the 4 ESC, we'll be powering is powered to the main power distribution board. So the power distribution board is connected with the power main battery power source and the engine power source, and you have a power module because the flight controller is operated under 5 volt. So that is why we need a power module, and that module will also be used as a power monitor. So that will give you the live voltage of what is the remaining voltage and what is the live voltage coming from the engine and from the battery. So based on that, you can calculate your entire flight time and you can monitor the system also. So mostly flight controllers having all those necessary components. I think you already know. The first one is GPS and compass is there, and safety button with LED, because everything is a power consumption object. That is why it is mentioned here. Buzzer is also a power consumption, and your wireless transmitter is also a consumption here. So that is why it is mentioned in this link. So and next one is your signal encoder. So all the blue lines are your engine components and the green line is your electronic components. So the engine components mainly consist of the battery. Sometimes the secondary battery will be using for the CDA system. So engine is absolutely having a spark plug and its CDA unit, and the engine throttle controlling servos will be there. And if it is a 2-cylinder engine, you have 2 CDA units, that is 2 spark plug will be there and the single CDA will be there. And if you are using 2 engines with a single cylinder engine, you need 2 servos in that. So like that we'll be using. The RPM is we'll be monitoring the RPM, because based on the RPM only the ECM will be there, the electronic control module. So that module will keep on monitoring the engine temperature and performance. So based on that, it will power the cooling system, because cooling system is very important. In case of fixed wing, cooling is not a problem, because fixed wing will keep on moving and air will be coming into the fins. So it is okay. But in case of drones is not higher speed, like maximum 6 meters per second we are using for agri drones. So as already sir told, based on the rice crop flying speed, best flying speed is 2 meters per second, up to 3.5 we will be clogging. So if it is 3.5 na, the wind speed is not enough to cool the engine. So that time we will be using a forced air cooling systems and liquid cooling system that is coming in the further slides. So so these are some of the hybrid generators that is available and we are using it. So mostly we import from Taiwan and China for this type of things, and the frames like cooling system and all we are making it here. So you have two engines listed here. One is a normal two-stroke engine with a forced air cooling system. This is the initial system. In initial stages, like 2 years before, this was the system. In this system, you can closely observe the engine power is used for powering the cooling system. So you can see the propeller shaft from the engine is belted with the cooling system. So you don't need to provide a extra ESC or extra motors for cooling. But in this system on the right side, you have a separate cooling motors, like ducted fans will be there. So that system will cool the engine in a separate manner based on the temperature rise. If the temperature rises too much, the the cooling system will be running too fast to make it optimal.
Mr. Nuri, you do have 5 more minutes.
Yes, ma'am. Yes. So, and we have the specs of air-cooled engine. So, air-cooled engine will be using this type of engine is there. So, 6,000 watts engine. So, it is weighs around 7.2 kgs. So, mostly we'll be using in a 16-liter drone. So, 16-liter drone is having the capacity of 45 kgs. So, you have seen here in the point max payload, it is 49 kgs. So, we'll be using up to 45 kgs drone. So in industrial applications like taking some payloads, we can go up to 39 kgs. Okay. So the working temperature is 20 to 45, but the engines can go up to 70 to 75 degree. It can go. So it is a self-start mode button option. So the starter generator is, while starting the engine will be acting as a starter motor for the engine. And generator, it is once the engine is started, the generators, the starter generator is converted into generator mode, so it will continue to produce the power. So next one is your these two are air cooled engines, and this one is a liquid cooled. So this is a critical layout of the system. So it is basic layout of your two-wheeler or the car. So it is having a radiator systems, and radiator means it is just a heat exchanging devices. So it will take the heat from the liquid is there in the engine, will take the heat from the engine, and it will go to the radiation system, and the heat is going to the air, and because the radiators will be fitted under the propeller. So propellers will keep on giving the air. So that will take the heat from the engine. So the engine temperature is maintained here. So it is a silent system compared to air cooled system, because air cooled system, the ducted fans will also produce noise while flying. So, but the water cooled systems having water pumps, so that will not produce much noise. Only the noise from the engine will be there. Mostly all those engines are two-stroke, because two-stroke is the very compact system for producing that much of power in terms of RPM also. So you have the system here. So it is a fuel injection type. So these two are normal carburetor systems. So gravity feed system is there. So it will automatically get the fuel from the tank. And this system is, we have a fuel pump is there. So that system will take the fuel. Okay. So that is a specification. Compared to this air cooled engine, it is 7.2 kg, but this thing is 9.8 kg, because this is because of two water pumps and the liquid that we are using, and the radiator system. That is why. Other than that, all are same. So we will be using this model for our clients for using the pesticide spraying. The tank is a 16-liter capacity, and you have an engine here. The motors are there. So these are some live photos that we are using. So in this photo, I am sitting over there. So, and this is a hybrid drone that we are doing. So these are some data that we are taking before delivering to the customer. Like, for example, we map an area um, in the mobile phone, so with the software. So with that area, what is the voltage the drone is while takeoff, what is the voltage, and while landing, what is the voltage, and while flying, how much voltage is dropping. So likewise, we are doing that. So if there is any service now, your exact photo, this is an exact photo taken last week from a client. So if it is mishandled, means the overheat will lead to the piston breakage, and connecting rod problem will be there. So you need to be the heat to be maintained every time. It is a water cooled engine. I think you can see the tubes here. So it is a water cooled, liquid cooled engine. So if it is not properly maintained, the coolant, you will have damages like this. A lot of other photos also there. So on above this, I am concluding my session. So what we have lot of energy sources available in the market, but as of now, we prefer the hybrid solution, because even the hybrid cars also now popular in our country. Like that, the hybrid drones are also now getting evolved from day to day. Initially, it was air cooled, now it is liquid cooled, and hydrogen cell is coming. So hybrid systems are mostly preferred here. So this is of my conclusion, and I thank everyone for listening my presentation. And this is our contact details. So if you have any doubts or on this, we'll be happy to clear you all those things. And that's it, ma'am. That's it, sir.
Thank you. Thank you so much, Mr. Nehru, for that very interesting presentation on insights into how we can power drones using greener technologies. Very much in keeping with the Sustainable Development Goals for the Agenda 2030 by UNESCO. Yes. I now open the floor for questions for Mr. Nehru. You may type it in the chat, and in the interest of time, you may open your mic and ask the questions. Okay, Samson, if you are asking a question, we would like you to just reduce the noise in your background, or you may type it in the chat or speak into the mic. Samson, do you have a question? Okay, I'll ask you. Okay, you closed your mic. That's fine. Mr. Nehru, what sort of prerequisites students would need to engage in, training at Aviation Tech, and how can they advance in that area in their career if they were interested in these sustainable energies for powering drones?
The prerequisiting is not much. If you are a starter now, you have to start with a battery powered system. So if you're advanced in handling the drone, then we can move for other power sources. So as a starter, the battery powered systems are mostly efficient. So if you know all those flying characteristics and everything, then we can easily switch over to alternate power systems like battery powered or solar powered. Because if any performance drops now, we can clearly watch and control the drone instead of crashing it.
Okay, and what has been the uptake in terms of placement in industry for persons with graduating from your program?
I'm not clear with your question. Put in chat, ma'am, because
persons graduating from your program, have they been absorbed into industry readily?
Yes, we have a lot of students. We are training every month, like 200 to 300 people. We are training like 2 days workshop or like 6 months course we are conducting. So if that is if they are graduated from our training academy, so they will be easily recognized in Indian companies like a lot of companies there like Idea Forge or even they can easily go for pilot licensing also. Like DGCA is providing pilot license in India, so they can easily go that. We are also into making licensing authority also, so that it is also already going. And if they are graduated from our institution, they can easily recognized in lot of reputed companies, because everyone in India knows the green tech aviation and AFI technology. That was a former company of aero modeling, so everyone knows us, so it is easy from our.
Thank you for that response. We have one question in the chat. What is the best drone model required to collect image data for analysis in academic research?
Yeah, if you are going for a ready-made, like if it is already a made model, ready to fly model, you can prefer DJI Phantom 3 or Phantom 4 Pro is better. So if you are an academic pursuing student, then you can use a Pixar flight controller and you can make a drone with a 450 mm frame that's available in the market. So with that flight controller, you can attach camera, or otherwise you can attach a lidar and you can attach thermal sensors. You can easily use your different data.
Okay, thank you for that response. We have one more question, and we'll take it from Gregory, the godfather. That's what we're seeing on the screen. Go ahead, Gregory.
Good evening, Mr. Nehru.
Yes, sir.
What is the potential? It is a multifaceted question, since it was an engaging this one. So very quickly, for entertainment purposes, for
yes,
display
sir.
drones,
yes, sir.
do we have any companies that provide these drones in India? Number one. And number two is, do we have commercially trained drone pilots for this? If so, where can I get those people?
Yeah, commercially trained pilots nowadays, a lot of people is there, sir. If you need them, you can contact us. And display drones, we can also prefer. What type of display drones you are looking for, sir? And what is the purpose of that?
No, basically, instead of using firecrackers, now we see in China and in Europe, there is a lot of display in the night sky, where it forms images and it creates graphics.
Yeah.
That kind of drones, is it available in India, or we need to?
Actually, drones are not available in India, sir, but the people is available, so they are importing from other countries and they are doing activities here. So if you want any particular shows, now we can call them. So they are telling estimate, so we can light show there.
Okay. And have you got any? How? Just this is an unrelated question, but it's a business question. Do you think there is a good market for this kind of display drones in India?
Yes, sir. For example, every New Year and Christmas, I'll nearly have 5 to 6 calls that are you displaying anything for Happy New Year or Christmas, like that. So like that, we have lot of requirements there, sir. Even nowadays, all the marriage functions, they are using flower dropping and camera for that. So they are using for taking the bride's things with the drone. Lot of different activities there, and this is also there. Lot of requirements there.
Okay, thank you so much for that very informative response. And we would now move to our final presentation by Dr. Umachandran, and that is entitled Industrial Drones Classification, Usage and Features. Over to you, Dr. Krishnan.
Thank you, Dr. Debra. I hope my screen is visible. As we progress through with listening from the experts, my presentation is going to be more onto the user front. Like, we are all fantasied over the use of drones. How do we use drones? And me being an industrial personnel, I would like to use drones in industry for the purpose of increasing productivity, safety, and the utilization of the resources in industries. Okay, so this talk of mine is going to be on industrial drones, classification, usage, and features. These are the factors which I'm going to touch. Of course, on to the introduction, industrial drones are like any other civil drones being done over this Indian skies. So Indian government has come out with the Indian drone rules of 2021. So they are going to control many of the drone applications. Of course, drone applications are all aerial, and it includes a lot of photogrammetry and digital twin in addition to the LiDAR. See, all these are geospatial mapping because it has a camera in the top, and so you can survey around, or you use a tool for spraying or surveillance or emergency response or transportation or defense, whatever it is, including the earlier question which went on displays. Okay, so it is more for enticing as well as for an application. These drones are normally classified into two forms. One is called the UAV, which is called the unmanned aerial vehicles, or the systems, which is called the remotely piloted aerial systems. These are the things which has been talked about throughout this workshop. Drones are now offering a more employment rather than being just a spectator to this use. There's a lot of opportunity to get employed or become an entrepreneur by using these drones, because these can reach, very versatile, and it's a very easy of use, and it can land onto inaccessible areas. So this part of drone usage, the drone technology, is being a diamond for the Indian government, where the Indian government is now thinking of going global drone hub by 2030. So by 2030, when our country wants to become a drone hub, then we need to have roles, and for this, they have created the rules called Indian Drone Rules 2021. See, the way how they classified the unmanned industrial drones is they divided it into 5. One is called the nano, micro, small, medium, and large. It all depends on the weight or the payload, including itself, what it can carry. So first is nano, which can go up to 250 grams. Micro is up to from 250 to 2 kilograms. Small is 2 to 25 kilograms. Medium is 25 to 150 kilograms, and large is more than 150. Up to 500 kilograms, drones are being used. The drones up to 500 kilograms are called as drone taxis. Okay, the usage of industrial drones, it is mostly for service delivery. Take something and deliver it into a specified location, or for surveillance of logistics with secured services, including cash transactions. And many of these survey for mapping or landing into places where you have hard to access or sources of contamination, or you go on to hotspots and containment zones where it is affected by diseases, including the currently run over COVID, and to also facilitate aerial vision. These are the uses where industrial drones are being applied. And for this, the industrial drones are now confined to the Indian drone rules. So the government is now opening it to industries with a good heart, like, they want to have a trust, self-certification, and non-intrusive monitoring. This is the preamble on which the drone rules are being charted in India. This is for giving a supernormal growth, and while balancing the safety and security considerations, these things are being evolved with. For this, the initial red tape removal is they have removed approvals like UAN, unique authorization number, or UPIN, that is unique prototype identification number, they've reduced. And they have also gone into reducing the forms, the number of forms that you need to comply with for using the drones. That has been reduced from 25 forms to 5 forms. And the fee has been reduced from 72 to 4. The types of fees that has been reduced in this favor for economical use of a business. See, when the certifications are getting reduced, that means it is to be handled either for the manufacturing or airworthiness, conformance, maintenance, import clearance, acceptance of existing drones, using the operator permits, how a R&D organization can use, or how a student can use a pilot license, or how a remote pilot instructor authorization can go, or drone pot authorization, all these are all covered in the Indian drone rules. It is more important to learn these, the rules before we start getting to use a drone, because it entices us. It's a toy which entices us to use, but without knowing the implications which we can get landed onto, it's better to learn and then use the drone. The next part is the advantage. Why an industry wants to use a drone? It's because, see, when you have people from remote, they can control many things. Then it reduces also the cash flow, because the country, which has given a reduction in the registration for your license also. Your remote pilot license has been reduced and it is having a validity for 10 years. So the cash outflow for an organization is considerably reduced. So every organization which wants to plan implementation of drones, they have reduced resources that are going to be spent. The next part is the digital sky platform. The government of India has started with a user-friendly online single window system, so that you log into it and you have a less bureaucracy control. So you have less human interference, and now many of the permissions can be self-generated because everything goes through online kind of an interaction. And then it gives out an interactive drone airspace map. This is the more important thing. If you want to use a drone, you should know where to use it. So you have a lot of zones being created with color codes like green, red, or yellow, where the green shows an opening with no permission you can use drones around, and yellow requires a kind of an ATC permission because you cannot go near an airport perimeter. So, but there also they have given a kind of a permission and they have extended the reach. Earlier it was a limit of around 45 kilometers, but now up to 12 kilometers before an airport you can use it. And in red zones, please don't try because it is security concerned areas. Whereas in CSR and welfare activities, where for you want to have people being protected or helped through, then no remote pilot license is required. And especially for micro drones, for nano commercial or for nano drones, there is no kind of limitation of license that is being required for using these drones. Next, coming on to the red tape. See, as we said, there is no requirement of type certificate, UIN, and remote pilot license, or for R&D activities you don't, unless if you own it and use it on a rented premises. And if it is in a green zone, there is no problem. And the more important part is many of us buy drones from outside, elsewhere from the other countries. So import of drones is being regulated by the DGFT. That is where Tommasi also said about the Directorate General of Foreign Trade and the DGCA, which the Directorate General of Civil Aviation. They have to give a clearance. But now DGCA clearance is not also required. You can just use one door, the DGFT, and get it. So no security clearance or issuance of registration or license is required for using a drone, provided, again, if it is used in the space of green. Coverage of drones has now been increased from 300 kilograms to 500 kilograms. So 500 kilograms is almost half a ton, which is nothing but to lift approximately a maximum kilogram of 4 people with 100 kilograms can be lifted. So you have a payload of a human being lifted and moved across the sky. So there's a great opportunity for the newer enterprises being evolved through drones. Then DGCA prescribes training. They also oversee drone training and they give the pilot licenses online. So you need not run around or rush around to waste your energy and resources to get a license for using the drones. Or there's no restrictions for foreign companies, to operate in India also. So of course you have to get registered as a company, and then you have to start using the usage of drone as your business. Then coming on to the license, testing, and certification. License is normally given by DGCA within 15 days. And you can also go with schools like what Nehru has been handling, authorized drone schools through digital sky platforms. These people can help people learn around or get skilled in the usage of drones. See, buying a drone is easy, but to know appropriately how to use it and where to use it and why to use it is the more important part. Okay, then the testing part of drones, if you see, the testing goes with the Quality Council of India through its authorized testing entities, and you get a type certificate through which you can use it in India. You can also import from other manufacturers. Exports are now exempt from type certification because even Tommasi was saying, it's more on the manufacturer side a commitment rather than the user side. So the type certification comes from them, and the unique identification number is to be registered with the Indian authorities. Coming on to the specific support. See, since 2016, drones have been going around the skies in India, but nano and small kind of drones are exempt from this kind of a certification. Importers and manufacturers, they use the UIN on the digital sky platform, and they do a self-certification route. So if you self-certify, then you need not go for getting a kind of a permission from the authorities. And onto the transfer and deregistration, you can easily do it on the digital sky platform itself, because once you buy a drone and you want to give it to somebody else, the name transfer is also like a vehicle transfer. So similarly, when the drones were being eased by India, there was a deadline set by the Indian government. They said before 30 November 2021. Now it's 22. So anything which happened before 2021, 30th November, the device acknowledgement number, and if there is a GST is already paid on the invoice, then these are already in the list of the DGCA approved drones. So you need not worry about any kind of hassles with the government authorities. Finally, the important part is on the standards. The standards, safety, and if you do an error, penalty, and the future promotion. See, SOPs, the standard operating procedures and the training procedures are already prescribed by DGCA. So no approval is required unless there is a significant departure from the prescribed route. So as long as you are abiding by what is in the rules, so there's no problem for using a drone. But if you wish to take a leap out of it, then means no permission, no takeoff, there the real-time tracking or a beacon or a geofencing, etc., then it'll be notified in the future. For now, compliances with the industry is if you are using this within 6 months of using it, starting to use it, you need to fill in your compliance. The maximum penalty for violation, it was earlier in many lakhs of rupees, and now it's about 1 lakh of rupees in Indian money value. For future, see, all these things are towards future. So the future promotion of drones in India is going to be with cargo deliveries, also with human movement. There'll be a lot of participation from academia, startups, and the growth-oriented regulatory regime, which can help in the prosperity of drones. For this, there is going to be a lot of drone corridors going to be developed. Like airports, we are going to have drone corridors. There we'll have a lot of stakeholders who will join together and get onto this mission of using drones for prosperity. Thank you very much.
Thank you, Dr. Krishnan. I think you put the icing on the cake in bringing it all together and helping us understand what it requires in terms of the rules and regulations and the Quality Council requirements for drones in India. I'm not sure if you intended to go beyond this area, but could you give us an idea of, in terms of the commercial use of drones, for example, outside of manufacturing, such as in retailing and wholesaling, even in the food and beverage industry, these pizza deliveries and so on?
See, drones can be used anywhere to anywhere. It's a great flexibility for our transportation. But what happens is these are all aerial driven vehicles. When it is going above the sky, it should not infringe with the movement of other aviation, regular civil aviation or military aviation. That is one of the constraints we have. Second, the overhead power wires and transmission, data cables or anything, those should not infringe with the movement of these, vehicles. So the more important part is, what is required is we need to have the aerial space, the third dimension, the height, which is infringing. It should not infringe with the movement of the drones. Otherwise, these things can be lifted up and dropped into any top of a house so that things can be delivered. It can go with the delivery of food. It can be going with the delivery of medicines. It can go with the spare parts. It can go with anything. From anywhere to anywhere, we can fly to the top of any house, provided if there is a requirement and a connection that is demanding them for a commercial gain. So then we can use this. So it's all in the upcoming. Now, a country like UAE has started using drones for taxis, and they are on a pilot mode. And they have also gone with the batteries being with the hydrogen fuel, like what Nehru was telling, more than the hybrid part. They have gone into hydrogen fuel, and there's supposed to be one more conference which is being held, and one of our World Resource member is also presenting a paper there. So we have a lot of things which are going on in this field, and so name that we can give, because this all technologies of Industry 4.0 goes with the creativity of the person who's going to use it. So the more creative people are, they can find out the use of all these technologies. Any of these technologies can be, go hand in hand or taken for a support for delivering what the country or people demand. So this is the way drones can also be used.
Okay, and we have one question in the chat. Can the drones be used in the hospitality industry, and how for commercial use?
Yeah, we can use hospitality industry. I can give you one example. There's a hotel called ITC Grand Chola in Chennai, which is hardly around 15 kilometers from the airport. There was a license seeking for a helipad on the hotel, but the government restricted because of various other reasons. Otherwise, even if a helipad was given, drone taxi would have come to Chennai in a much faster rate. We already have drone taxis being on a model run in Chennai. There is a company which has already initiated, and it has started making drone taxi available. We have been using drones for lifting patients' parts, like heart and liver and kidney, etc., from the deceased person, and who's volunteering to transfer it for the patient who deserves to be harvested with it. So these things are already happening in India because of the technology revolution. And we have good specialized setups in India, especially in Chennai, where the curriculum part all go with much enhanced learning compared to any of the world leading countries giving through an academic input. We have such. It's all in the process, and it's evolving.
Thank you, Dr. Krishnan. Do we have any more questions? We can take one more question for Dr. Krishnan. You may open your mic or you may type in the chat. So the future is indeed very bright for drone technology. We just have to continue with the momentum. We hope, okay, I think there's a question coming through. All right, I thought I heard a question from someone. Is there a question coming through over the mic? All right, so on behalf of World Resources webinar, I would like to thank sincerely our presenters this morning. You have certainly helped us to deepen our knowledge on drone technology with regards to rice farming, how the drones can be applicable there. We also learned about the certification for drones with respect to the application of DO 178 certification, the benefits and the costs, And we have also gotten the educational side of it from Mr. Nehru in his programs, where he helps students develop greener technologies for powering drones and the lucrative careers that are, forthcoming in that area. And then last but not least, from Dr. Krishnan on the classification of industrial drones, the rules and regulations, and the features that the Indian government have put in place for their use. Participants, students, all from around the world, we hope that these webinars on drone technology have certainly raised your awareness and interest and stimulation for furthering careers in drone technology. In whatever area you are, it is certainly an area that is very lucrative and very promising for the future, particularly in meeting the Sustainable Development Goals for the Agenda 2030. We will be sending you the link to the video and the PowerPoints that would be sent to you. We ask that you fill in your information on the attendance register, including your correct email and the name that you would want to appear on your certificate. I will just ask Dr. Krishnan if he has any other closing comments before I close off.
Dr. Deborah, can we have participants open up their camera so that we can take a picture also of the participants?
Yes, please.
So that can go over the yeah, please.
Yeah. So we
Request
would like
everyone
for you to open your cameras so we can have a screenshot.
Please.
For the video, please.
Yeah. Others?
Dr. Krishnan, I would leave it to you to do the shot. You'd have to go panel by panel. or whatever you. Okay,
I think with whomever is available, we'll take it. Yeah.
Okay. Okay. Georgian,
Right. No
could you
issues.
open your screen? Yeah.
Yeah.
Thank you. Thank you.
Thank you. Thank you. Thank you. Okay.
Miss, I was unable to open my camera, so I don't know what it is.
No problem. No problem.
It's okay. It's okay.
Okay. So I'll take cheese. Okay. We'll go the first team, right?
Thank you.
1, 2, 3. Done. I'll go to the next sheet. Next sheet is more of names. Anyhow, we'll capture that also. All right. Thank you. Thank you all.
Okay, so do enjoy the rest of your day, and we look forward to having you again in the forthcoming webinars by World Resources Webinar. I now bring this session to a close. Thank you.
Thank you. Thank you. Thank you, Dr. Nurfaiz. Thank you, Dr. Deborah.
Thank you, Dr. Krishnan, Dr. Deborah. Everyone.